Alright, so for number 10, we have a word problem. So all we really need from this is this equation and this. Alright, so we have a position function and we have an interval. So it says find the average velocity of the car over the first 3 hours. Okay? So velocity average is change in distance over change in time. So it's going to be s of 3 minus s of 0 all over 3 minus 0. So we get 4 3 cubed minus 12 3 squared plus 9 times 3. If I plug 0 in, it looks like this is, I think, s of 0 is going to be 0. So minus 0 if we want to write that. Okay? All over 3. Okay? It looks like this is going to be equal to 27 over 3, which is equal to 9. Awesome. Now, we're asked to show there is at least one point in the time after the beginning of the trip, but before the 3 hours has passed. Okay, so 1 point between 0 and 3, where instantaneous rate matches the average velocity. All right, well, we already found the average velocity, right, of 9. Okay, well, instantaneous, this tells me it probably has something to do with the derivative, right? Because the derivative is the instantaneous rate of change. Okay, so we need to find the derivative of this position function, because the derivative of position is velocity, right? If I want to get from one to the other, I take a derivative. So velocity is going to be the derivative of s of t, which is going to be 12t squared minus 24t plus 9. So this question is asking me to find when this is equal to 9. Okay, so this is the instantaneous. This is the average. All right, so let's see, what can we do here? Well, I have a common 9, so if I subtract the 9 over, I'm going to be left with this right here. Okay, and these have a common 12t, so 12t, t minus 2 is going to be equal to 0. So this is true when, when 12t is equal to 0, or t minus 2 is equal to 0. So we get t equal to 0, t equal to 2. But it says after the beginning of the trip. So it looks like this guy is going to be our answer. Okay, moving on. Identify where the acceleration changes sign. All right, well, we don't have acceleration yet, but we have velocity, and guess what? The derivative of velocity is acceleration. So acceleration is going to be v prime, which is going to be equal to 24t minus 24. Changes sign. This means I want the critical point. Yeah, okay, so I'm gonna set this equal to 0. I'm gonna find where the acceleration is 0 because everywhere else it'll be positive or negative, okay? This is the critical point of velocity, by the way. Okay, so if I pull a 24 out, I'll have t minus 1 equals 0. This is only true when t is equal to 1. Let's confirm this is true. Let's see what's happening before 1, and let's see what's happening after 1. Let's try 1/2 and 2. And let's plug in to our acceleration. I plug 1/2 into here, I'm going to be negative. I plug 2 into there, I'm going to be positive. So it looks like acceleration is in fact changing sign when t is equal to 1, because that is when the acceleration is equal to 0.